Hey everyone, it's Bob Crossan, Senior Managing Editor for Water and Waste Digest. I am here today with Trideep Barua. He is the Global Infrastructure Segment Manager, Electrification for ABB, and we're going to be talking about water scarcity and technologies that are being used to address this problem globally. So Trideep, thank you so much for being here. We really appreciate you taking the time. Let's start first by talking about some of the high-level challenges, specifically with like desalination and groundwater recharge. What are some of the core high-level challenges that you see with those particular things in this industry?
Sure. See, water is a process-based industry which involves treating water through different stages of filtration and purification
Hmm.
before it is suitable for human use, right? So in that sense, it is very similar to other process industries like chemical, oil and gas, metal and mining, which
Hmm.
relies heavily on automation and control to drive operational efficiency. So comparatively, the water industry is only about starting when it comes to adapting these new age technologies, right? To in particular to resolve some of its challenges like energy usage and transportation of water.
Hmm.
Desalination, we all understand, is one of the key technologies when it comes to making water affordable and available to the large masses. Over the years, we have seen significant improvement in desalination technologies. If we talk about energy recovery devices, if we talk about the whole shift to membrane-based processes, the
Hmm.
pre-treatment itself, and the membrane technology, if we talk about. But more needs to be done to make the desalination process more intelligent and more smart and more efficient. Uh, there is still a significant challenge surrounding the energy, high energy required in
Hmm.
desalination systems, right? And this is more true for seawater. Typically, seawater salinity is much larger, 35,000 milligrams per liter of dissolved salt as compared to industrial water, which is around 1,000 milligrams. And typically, energy consumption in a desalination plant is around 3 to 4 kilowatt hours to treat a cubic meter of water. And typically, electrical energy cost is around 45 to 55% of the total operational cost. So it is a significant factor, right,
Hmm.
which needs to be taken care of. Another challenge is the water losses, and this has to do with the age and management of the desalination plants. 40 to 50% of the treated water is actually lost from its point of treatment to its point of use, right? And half of this is in the developing nations. So a lot needs to be done when it comes to the water losses, which we also call, by the way, as non-revenue water.
Hmm.
Uh, Another challenge is the traditional equipment in desalination plants, which it means. And if you look at it from an electrical landscape, it gives limited visibility as to what's happening in your plant. So most of the time, we are actually working on a reactive mode rather than being proactive, right? So the time is right, I would say, to move on from a more reactive approach to a more proactive, and then finally to a predictive,
Hmm.
mindset when it comes to solving these problems. If we talk about groundwater recharging, now groundwater is an invisible resource, right? Which is rapidly depleting,
Hmm.
given the increase in demand and over extraction in the last years. If you look at the major aquifer systems across the world, you talk about the Ganges Brahmaputra Basin, you talk about the North China Plain, you talk about the Central Valley in California, all are receding, right?
Hmm.
Um, uh, and if you look at understanding how groundwater recharge works, it's actually quite complex and challenging.
Hmm.
Because it is basically influenced by how much it is going to rain, what is the frequency, what fraction of that will be evaporated, right? What fraction will actually turn into runoffs, and how the surface and the groundwater systems are connected, right?
Hmm.
So the climate change and its effect has a significant role to play here. I think another additional challenge that I see when I look across is the devices, the measurement devices available today for measuring groundwater recharge is rare, or is not up to that standard when it comes to technology. So we have a few issues to deal there when it comes to groundwater recharge, right?
Yeah.
So overall, if you look at depleting groundwater levels, is one challenge, but the bigger challenge is also the quality of the groundwater that is available because of increasing use of fertilizers and chemicals, and the lack of infrastructure when it comes to collecting, treating, and reusing the surface water, right? And
Yeah.
additionally, when you look at if you look at both together, both desalination as well as groundwater recharge infrastructure is pretty high when it comes to energy use. So these are some of the overall, I would say, factors which I see as major challenges in this space.
Yeah. So I wanted to pivot a little bit toward like the other side of the equation about how water scarcity is becoming a problem. What are some of the things that you are seeing contributing to that? You mentioned climate change being one of them. In the U.S., obviously out west, we're seeing a lot of drought conditions and
Yeah.
Lake Mead at historic lows and things like that. What are some of the things that you all are seeing as drivers to why water scarcity is becoming a growing issue, at least in the U.S.?
Okay. Um, uh, I see it this way. Say, US has a pretty fragmented water grid, right?
Yes.
It has approximately around 52,000 community water systems. Compared to, if you compare to that to electrical utilities, it is, I think, around 3,300, right? So it's quite fragmented, which obviously leads to the effects of low cost efficiency, lack of capital investments, and also lack of operational expertise, right? If you look at US in particular, the water network was developed quite early as compared to the other countries, and this was done with the technology of the day, right? So which is aging. So the factors that we talked about earlier on the challenges around water leakages and about technology giving limited visibility into the operations, all this impact the way water is basically managed, and the water supplies in the country. Also, water management, what we do with the managing water of the surface, right? Every year you will see that excess water because of flash floods, because of high tides, because of heavy rain, and this also goes and damages our infrastructure, right? So how do we have an infrastructure wherein we are able to collect,
Hmm.
treat, and reuse this water? I think that is the crux. So basically, I always say that reuse is the new water, right?
Hmm.
Because here the idea is to do more with less. Mm.
Yeah.
So yeah, so that is the focus. On top of it, of course, there are the global factors like climate change and its effect on weather patterns. So that's significant. Rapid urbanization that happened, large scale industrialization are some of the other factors, right? US specific, if you look at effect of these, as you said, mentioned, the latest report of the US Drought Monitor, 20% of the US population is actually living in drought affected areas. And interestingly, 99% of Western US is actually in drought, right?
Hmm.
If you look at Lake Mead, the largest water reservoir in the US, supplying water to nearly 25 million people in Las Vegas, in San Diego, in Los Angeles, it has reported lower water levels for the first time since its inception in 1930s. Right.
Hmm.
The Colorado water system is at 40% capacity. It was 49% last year. So in a year, 9% reduction. Right. So much so that a couple of days back, I was hearing a report that water will now be traded in the
Hmm.
stock exchange in California. So this kind of shows the gravity of the situation, right? Uh, See, I see that water scarcity and depleting water levels in the ground is now a global problem. It's no more US specific, right? And here, the one of the prime reasons is there is a general thinking amongst the developed world that water problem is not theirs. It is
Hmm.
not going to affect them. It is not going to affect their city, their state, their country. And this is a problem of the developing world, right? And probably that is because we see water all around us, right? without realizing that 3% of the water that is available on Earth is only usable, right? So I think public awareness and sensitivity to water as a very precious natural depleting resource
Hmm.
has to be developed, has to be built. Um, uh, because otherwise, we keep talking about the same problem without really looking for solutions.
Yeah, absolutely. That interconnectivity, that whole one water mindset, it all makes sense why that is becoming a much bigger framework of discussion in the water industry when we're
Right,
talking about how that what you just said, how certain countries may be like, oh, well, it's not a problem for us. It's like, well,
right,
it
right.
is because the problem halfway across the world is influencing your specific problem because all water is connected,
Absolutely.
right?
Absolutely. And these aquifer systems under the ground are connected. Yeah. So
Yeah.
if you're polluting one aquifer, it kind of flows in under the ground,
Yes.
and without you realizing you're part of the problem. Yeah.
Yeah, absolutely. So pivoting a little bit toward the technologies here, could you talk about electrification and how you guys are using electrification to try and solve some of these problems and issues that you've enumerated so far?
Right. I think the world is moving away from fossil fuels, and electrification is being embraced and adapted more and more. Right.
Hmm.
In our daily lives. We have already seen that happening, for example, in transportation. We all know the kind of magnitude we're looking at when it comes to electrical vehicles. We have now electrical ships, and we are now even talking about electrical aircrafts, right?
Hmm.
But from an electrification standpoint, I think what is significant in terms of how we solve these problems is more towards how we manage energy, right? We looked at the problems of energy, how energy cost is a significant OPEX contributor.
Hmm.
45 to 55% of OPEX is on account of energy. So energy management has become a very critical area, especially also because of the global energy cost going up
Hmm.
and up on the day, right? So real-time control and monitoring of energy distribution and energy consumption based on the demand is vital today now to improve energy efficiency, right? Here it is important then to have an ecosystem of digitally connected products and systems, which acts as the eyes and the ears
Hmm.
of the energy landscape, giving complete visibility of what's happening in the network, basically enabling plant operators to take timely decisions, thereby avoiding costly breakdowns, right? And of course driving efficiency. From an ABB point of view, ABB ability based solutions on energy and asset management helps solve quite a few of these problems that we talked about.
Hmm.
Data shows that we easily drive cost efficiency in terms of energy by around 20%, operational cost by around 30%, and of course we certainly avoid 100% unplanned labor because it gives ahead of time information to the person concerned or responsible about a possible failure that might occur, and they incurring breakdown costs and things like that. So these are some of the areas that electrification comes in and helps
Hmm.
address these problems.
Yeah, cool. Well, it sounds to me it's kind of tangent. Interestingly, it seems like it's mirroring the one water conversation that everything is connected, which is really
Right,
kind of
right.
a fun little
It is,
element to
yeah,
that actually.
yeah,
Um,
yeah.
what are some other things that are driving the market in terms of desalination, groundwater recharge, in those market sectors? What are some of the things that are driving new equipment or solutions forward right now? And
Right,
how are you and ABB trying to meet those challenges head on?
right. Uh, see, the water industry over the years and as we speak is undergoing a massive transformation, right? We see a lot of focus on decarbonization as a subject. There's public-private partnerships coming
Yeah.
along. More and more global supply chains being activated. We see common technical standards which are being used to develop these plans. and technology as a whole is going through a massive shift. Even when you talk about water. Decarbonization, we spoke a little bit. There's a major shift to renewables sources of energy,
Mm-hmm.
moving away from the fossil fuels. So we have a lot of solar, wind, hydro in terms of more and more usage. There's a lot of focus on hydrogen as an energy carrier. There is then storage, energy storage solutions which are coming in. So the idea here is how do we integrate more and more of renewables and make the operations more and more cleaner and greener. So that is something which is driving this space. Moreover, second important aspect is the economics of water, right? Which is driving. As private players build, own, and operate water plants, the whole focus has shifted to technology, and this is driven by profitability and total cost of ownership, right?
Yeah.
So this area will further then drive the adaptation of digitalization, because the whole focus then is to reduce how to reduce the cost of treating water or desalting water, right? Moreover, as looking at the water industry a little differently, I think one of the important and the new, let's say, focus areas that is coming up when we talk about desalination is how do we manage the brine, right?
Yes.
Brine till the other day was something which was considered to be a toxic waste, and there are challenges how do we deal with it, right? But brine management can create alternate revenue streams, right?
Okay.
Helping offset the cost of water and basically balancing the cost revenue equation of desalination, right? So brine management, it is important because on one hand, as I said, it has a high concentration of salt and chemicals, which if disposed irresponsibly can really harm your soil and vegetation. But on the other hand, if you treat it and if you refine it, then it also becomes a very important source for important minerals and chemicals like industrial grade salt, caustic soda, magnesium, potassium, calcium, and you name it, right?
Yeah.
So that's a very important industry. In fact, if I look at some of the large projects, we are talking about an alternate industry around brine and desalination and treated water being a byproduct. So the equations are actually turning the other way around, right? Because there is a significant market that people see when it comes to how brine can be refined and sold, right?
Yeah.
On groundwater recharge, there I think will be an increased focus on smart sensing and
Okay.
measurement, not only on the quantity of water but also on the quality of water, right? Because of the challenges that microbes present to human health. Another factor is increased accountability on the industrial side, because industries now realize that a lack of fresh water is going to impact their operations. So the whole question of business viability, return on investment, profits, all goes for a toss if they don't ensure that sufficient water is available. So actually, the industrial interest in water is actually making groundwater, which is invisible today, more and more visible, right? So I think that is something that will go. So if I have to sum it up, it's basically more governance, more technology, and economics, which will basically drive sustainability and water stewardship in this area.
Yeah. So where do you see technology going to meet those things head on? Like you said, the smart sensing and stuff. Obviously, people are already developing a lot of smart sensors.
Right,
What's
right,
kind of the next evolution of that? What's the next evolution of the energy efficiency for desalination? What does that look like to you?
right. See, technology is evolving very fast. I mean, if you look at what has happened in the last 10 years, we are in a
Hell,
totally
heck, the
different
last
world, right?
five.
Right.
Just the last
Exactly. So
five.
exactly. So we can talk about in terms of technology, we can talk about the short to medium term, right? And as you rightly said, it could be around 5 years. I think technology for the next 5 years would be primarily focused on reducing water cost, right?
Okay.
Reducing the cost of treating water, and without affecting the environment in any way. I think that is
Hmm.
where the main focus of the technology of tomorrow would be. And digitalization will significantly change how water projects are planned, built, and operated in the future, right? And with that, the new technologies that will come along will advance the groundwork needed for effective digitalization. Because we talk about digitalization without realizing that what is needed in the first place to make effective digitalization, right? So here we are talking about developing a network of smart sensors and meters, which can be then processed by a dynamic control system, right? So at this moment, the water industry has very much adapted, like I said, for the process industries, automation and control technologies. But I think going forward, there would be a lot of with digitalization kicking in, there would be a lot of focus on data. How do we collect data? How do we store data? How do we analyze data and give meaningful insights to the people who matter, right?
Hmm.
So with that as a background, I think two or three very clear technologies which will affect these areas of interest comes out. First is the digital twin,
Yeah.
which is basically the virtual copy of the water system, right? It helps water operators to make better decisions, because first of all, it gives a holistic view of the water system and helps simulate situations which are real as well as what if.
Hmm.
So that kind of exposes the water operators to different scenarios that is possible for them to plan and design, right? And here, if you talk about the digital modeling software, it can aid the design of new effective desalination plants, for example, which significantly reduces the capital cost, right? And here we can talk about a few examples. The RO system configuration with high recovery rates can reduce the pre-treatment design of the pre-treatment systems, for example, providing significant capital cost savings, reduced load on the operator, and overall operational efficiency. If I talk about the energy space, we can have effective design of the energy, optimized design of the energy management system, considering the peak loads, considering the tariff and the cost of energy, right?
Yeah.
So that's one area. Second area I think would be on the artificial intelligence and machine learning space, right? Uh, Now with more and more IoT enabled products, this whole space has exploded big time, right? So there's a lot of data that is available today, but meaningful management and analysis of data driven by artificial intelligence and machine learning is what is going to drive your efficiency overall, energy as well as operational, right?
Hmm.
I think machine learning solutions offer great reactivity on the operational side, which otherwise is not humanly possible. If you look at artificial intelligence, it looks at previous data uh, to train the system so that it is able to predict and analyze and give different scenarios to the user so that they can take a more informed, meaningful decision towards the benefit of the plant, right?
Yeah.
So currently, these solutions they are available as a software as a service model, right?
Yep.
Which can be used for achieving different operational goals, whether it is better energy efficiency, whether it is predicting the life of the membrane, whether it is to reduce the operator workload, or even reducing chemical consumption, right? Uh, and the third area, which is significant, is cloud computing. I think that's one space which is a very important building block when it comes to efficient water management, right? I think the cloud's ability to dynamically scale, depending upon the additional scope and the number of users is unmatched. So
Hmm.
that's one area which is significant. It also provides a much deeper ability to collect, analyze data, and provide that data and share that data with customized analytics
Hmm.
to a large set of people. for them to make meaningful decisions. And this can again be leveraged from anywhere, and it can be given to specific people depending upon your responsibility. So, for example, the energy usage patterns can be given to the top management so that they can analyze, how the energy consumption patterns are working out, are panning out. Predictive maintenance data could be given to the maintenance managers so that they can plan ahead of time, thereby avoiding costly breakdowns, and and also to the level of a warning of a device failing or a temperature rising in a particular joint to the field engineers who are on the ground, so that they can go ahead of time and avoid that breakdown. So these are the different technologies that currently are being used sparingly, I would say, but more and
Hmm.
more water companies are looking at them seriously. And when you talk about cloud computing, there is also this concern about data security. I think
Hmm.
there's a lot happening in that space as well to ensure that the data belongs to the customer, and then a lot of areas around what they can do with that data in terms of the functional capabilities, which of course
Yeah.
is entirely different when that data is managed in premise. So
Yeah.
these are some of the areas which I see will significantly change the way water industries will work in the future.
Hmm. Well, Treaty, thank you so much for talking with me today. Learned a lot. We covered a lot of great ground today, so I really appreciate you taking the time to talk with me about it. And for everyone who's watching, check out the video description below. We'll have some links to some things on our website, as well as an ABB link or two about some of their things that they've got going on when it comes to water scarcity, groundwater recharge, and desalination. So be sure to check that out. And once again, Treaty, thank you so much for being here. We really appreciate you taking the time.
Thanks, Bob. Thanks again for having me here.